Hello and welcome. Today, we're going to look under the hood at the engine that drives so much of modern AI. We're going to explore this really fascinating question. How can a machine learn to do something incredibly complex without a human programmer telling it exactly what to do?
So let's start with something you probably use every single day. You know how your phone just recognizes your face to unlock? It happens in a split second, right? It feels seamless. But what's happening there is actually a huge leap in how technology works. Or think about this. You're traveling, you see a sign in a language you don't understand, and you just point your phone's camera at it, and boom, you see the translation right on your screen. This stuff used to be pure science fiction, but now it's just a tool we all have.
And it doesn't stop there, it goes way further. Right now, we have AI that can create incredible art from just a few words of text. It can write articles that make sense. It can even pilot a car through the chaos of a busy city. Okay, so here's the twist, the part that's really mind-bending. For all of these amazing things, no one ever wrote code that says, hey, if you see this pattern of pixels, that's a face. Or if you hear this sound wave, that means hello. The programmers, they didn't write the rules for how to do any of it. And that leads us to the big question for today. If we aren't spoon-feeding the machine instructions for every little thing, then how on earth does it learn to do these things that feel so intelligent?
The answer, it turns out, is something called a neural network. It's a system that's designed to learn from experience, kind of like how we learn.
So what exactly is a neural network? Well, the simplest way to think about it is as a pattern-finding machine. That's its whole job, find patterns in data. Now, the name was inspired by the neurons in our brains, but we have to be clear, it's a very simple version of that idea. Let's break down the building blocks. First, you've got artificial neurons, and these are just simple little calculators. These neurons are organized into layers. Information moves between these layers through connections. And then there's the most important piece of the puzzle, weights. A weight is just a number attached to a connection that says how important it is. It controls how much a signal from one neuron affects the next. And this is absolutely key. These weights, they are everything. This is where the knowledge is. The skill of recognizing a face or translating a sentence isn't written down in lines of code. It's all stored or encoded in these millions of numbers, the weights. So how do all these simple little parts come together to do something so powerful? Okay, let's zoom in on just one of these artificial neurons. What it does is actually pretty straightforward. It gets numbers from other neurons. For each number it gets, it multiplies it by the weight of that specific connection. Then it just adds all those results together. Finally, it takes that total sum and puts it through a simple function to decide what number to pass on. And that's it. On its own, one neuron isn't very smart at all. And this really gets at the core difference here. With traditional software, a human programmer writes explicit rules. If this happens, then do that. But with neural networks, it's a totally different game. We don't write the rules. Instead, we show it a ton of examples, and it adjusts its own internal logic, those weights, to find the patterns on its own. And that's why it's so good at messy, real-world problems, like telling a cat from a dog, where you could never possibly write down all the rules. So this leads us right back to this central question. How does the machine actually learn? How does it go from a state of knowing absolutely nothing to being able to do these incredible things? Well, every training process begins with total ignorance. Seriously, when you first create a neural network, every single one of those important weights is just set to a completely random number. It knows nothing. It's a total blank slate. The learning happens in a loop that just repeats over and over. Here's how it works. First, we show the network an example. Let's say a picture of a handwritten 5. Then, based on its random weights, it makes a guess. It's probably going to be wrong. So, third, we measure the error. We have a way to calculate exactly how wrong its guess was. And finally, this is the most important part. The network adjusts all those weights, just a tiny little bit, in a way that would have made its guess a little less wrong. This whole process of adjusting the weights has a name: backpropagation. A really good way to think about it is like tracing the blame. After it makes a mistake, the network works backwards to figure out which of its connections and weights were most responsible for that mistake. Then, it just gives them a little nudge in the right direction. And when I say this loop repeats, I don't mean it happens 100 times. We're talking millions or even billions of times.
And with every single one of those cycles, the network's weights slowly, gradually shift from total randomness into a highly structured system that actually represents the patterns it's been seeing in the data. But this is a really important point to understand. The network doesn't understand what a number 5 is, not like we do. It has no concept of mathematics or writing. It's just learned to recognize a statistical pattern of pixels that, in the data it was shown, almost always had the label 5 attached to it. Okay, so what does this incredible pattern-matching ability really mean for us in the real world? It's time to look at both the amazing power this gives us and the very real dangers and limitations. This way of learning has turned out to be unbelievably powerful. It's the technology behind computer vision, how machines recognize objects and photos. It's how voice assistants like Siri or Alexa understand what you're saying. It's what powers translation and even AI that writes for us. It's everywhere, from predicting the stock market to the recommendation engine that decides what you see next on social media. But we have to be really clear-eyed about the serious limitations here. For one, training these things takes a huge amount of data and a ton of energy. They're also what we call a black box. They give you an answer, but you often have no idea why they gave you that answer. They can also be wrong with incredible confidence, just making things up that sound totally right. They can inherit and amplify any biases that were in the data they were trained on, and they don't reason or understand things the way people do. So, as we wrap this up, let's be absolutely clear on a few things. These systems do not think, they do not understand, and they do not reason.
What they do is adjust millions and millions of tiny numbers over and over until the patterns that shake out of that process start to look intelligent. And that appearance of intelligence is proving powerful enough to change just about everything.
And so that leaves us with the real question we need to be asking. It's not, are machines becoming human? The real question is, are we ready to guide systems that can learn so powerfully, but do so without any judgment, any ethics, or any real understanding of the world? That's the challenge ahead. Thanks for joining me for this explainer.